All right, moving on into some statistics here. So for Chapter 8 and Chapter 10, so here we go. Set of numbers have a mean of 12. Another number was thrown in there, value of 47, and it became a new mean of 13. So before the inclusion, how many numbers were in the set? So just think of basics. How do you find a mean or an average? You take the sum of all of the numbers, divide it by the number of terms, and that gives you the average. So if we were to throw in another value of 47, that means we have our previous sum plus 47. There's also one more term, so now there's n plus 1. We know the new mean is 13, and so we get that look right there. So it's kind of just like solving a system of equations by substitution. If you look at the first case, I just multiply the n over to tell me that the sum was 12n, and now I can sub that into my other equation. And so now I know that 12n plus 47 over n plus 1 is 13, and now we're just solving that for n. And so now I can just multiply my n plus 1 over to the right, which is where you would distribute the 13. So that gives you your 13n plus 13. And then, of course, if you subtract 12n, that just becomes n. Subtract 13, and you're down to 34. So that was the number of terms. This one is asking for a sum. Or no, it wasn't. It was asking for the number of terms. So that's all we were solving for. So there's our answer to that guy. Moving on. So we got a table at the right. So it's got number of TVs. We got number of families who own that amount of TVs. So for the first question, the total number of televisions owned. So this is one we just got to use a little logic here. So 3 families had nothing. 6 families owned 1. 8 families owned 2. So that's 16 TVs. All right, that was 6 TVs plus 16 plus 27 plus 12 plus 5. So you're just kind of multiplying and adding as you go to figure out the total number of TVs. If they were to say what was the total number of families, we would have just added those together. But this was total number of TVs, so it's just worded a little differently. Mean number of televisions per family. There's 2 ways you could do this. One is by hand, just to how you basically find a mean, right? You add up all the terms and find the sum, divide by the number of terms. So we would have just said, let's find all that sum that we just came up with a minute ago. Divide by the number of terms, which would have been the number of families, and you can get your mean televisions that way. And that's not a bad way to go. Let me just quickly remind you of a calculator option that we got for this too. So for this one, if you go to Stat, go to Edit, you can put that information into List 1. This would be like your frequency list, so that's List 2. Because remember, that's just how many families own those guys, so that's your frequency list. So you can see I've already put those in. If you go to Stat, jump over to Calc and do the one variable statistics, because remember that's just one variable with a frequency list. All these are here for is to tell you how many variables how many numbers you have for those variables. So one variable stats, list 1 was our list of data, list 2 was our frequency list. So if you just hit enter all the way down, you see up there at the top we have the mean. Again, this would have told you the answer to part 2. That's the sum of all of your x's that we would have had right there. So that could have been your answer for the first part, for 2a. We did the sum of all those divided by the number of terms in order to get the mean. So they kind of even tell you where all those numbers come from. So kind of nice feature to use on that. Going on to 3. So we got a mean of all those scores is 18, so solve for k. So really the same idea that we're using on number 1, but now we're just solving for a missing term. So for these guys, setup for that would just be similar to how we started the first part. So if we just were to find a mean, we'd add up all the terms. So I got 3 15s, so that's 45. I got 5 16s plus k 17s. Plus 14 18s. So right, we do the math on that and we add all those up, and that's our sum of all the data. The number of terms is the sum of your frequency list. So if I did add up all those together, that bottom row, that's the sum of all my terms. That would be the denominator, and I'm going to set that equal to 18. So just for the sake of time, let me just show you. If I'm sure you've already seen this, but you're right, this is how that looked in the worked out solutions. So here's kind of the math set up for what I was just describing to you. and we're setting that equal to 18, and that's pretty simple algebra from here to solve. So if you combine like terms, that puts you to this step right here. Multiply your k plus 42 over to the right and distribute the 18, and then just continue solving for k. So we figured out that k was 8 based on that. You just note that. Alright, so now we can find the standard deviation, and this is where that calculator just comes in handy. So we're going to go back into stat, go to edit, to clear out your old list if you ever need to. Sorry, hold on, I'm trying to show you all that at once. Just go all the way up to the top, hit clear, hit enter, clear, enter. So if we put in our data, so we have our x's, oops. So we got our x's, 15 through 20, and then now we have our frequency list. Now that we know that k is 8. So you got your data, go to stat, go to calc, one variable stats, make sure it's showing list 1 and list 2 for the frequency list, go all the way down, and then you got 2 standard deviations. Remember, the one that we use is the one with the little o. So that little o is actually the lowercase sigma, so it's like the lowercase symbol for him. This is used for a sample of data. This is used for a population of data, which we always use the population, so you always want to use this standard deviation right here. So 3 sig figs, 1.39 should be our answer for that. Jumping on to number 4. So 50 families, so we know our frequency list, we got 50 families. We're asked to give number of people in their home. So that's all described in the table. We know the mean was 2.6. So find the values for A and B. Pretty similar to what we did up above. There are 2 unknowns, but they do give us a little more information on this one. We know that the sum of the frequencies is 50. And so I know that if I add the bottom row, I know I can set that equal to 50. And so there's one setup that we can have. So if we combine like terms, what do we got? 23 plus 5, so 28 plus A plus B adds up to 50. Thanks to that first statement. If we were going to do the mean, so remember how we've done that so far, right? We'd say, well, I got 12 of those, 2A of those, 33 of those, 4B of those, and 25 of those. So if we add all those up and divide by the sum of all the data, which is 50, we can set that equal to 2.6 and go from there. All right. So let me give you the quick setup on that. So we do have 2 unknowns. We're going to end up kind of solving a little system of equations here with substitution. Couple things I can do. One is subtract that 28. So I do know that A plus B is going to be 22. So that's one thing we know already. If I set up my process for the mean here, so remember what we were talking about already. I have 12 times 1 plus 2A plus 33 plus 4B plus 25, and we're going to divide that by the total number of terms, which is 50. We know we can set that equal to 2.6. So starting a little math on that, so we're going to multiply the 50 over to the right. I'm going to combine like terms on the left. So a little simplify here. I got my 2A, I got my 4B, plus a remaining, looks like if I add those up, 45 plus 25, so 70. I'm going to multiply my 50 over to the right, so 50 times 2.6 is 130. So subtract the 70, and we know that 2A plus 4B is equal to 60. Just to make life easy, I'm going to divide everything by 2. So A plus 2B is equal to 30. So now we can use a little like substitution from what we already know. So if I kind of back up to this, I know that if I subtract B, I know that A is going to equal to 22 minus B. So I can sub that in. So 22 minus B goes in for A. And I just continue solving for what I have here. So anyway, a negative B plus 2B is just 1B. subtract my 22 over from the right, and I now know that B is 8. And if I go back up to that statement right there and plug that back in, I can solve for A and get 14. All right, moving on. So let's jump down. Let's go to number 9. So we got a set of numbers right here. A couple unknowns. We know the mean is 9, the median is 10, and A has to be smaller than B, so figure out what those numbers are. So here we go. We know the mean is 9, so think of how we've done this in the past. If I find the sum of my terms, so if we start adding those up, so 20, 31, 46, 64, 68. So 68 plus A plus B. So that's the sum of our data. The number of terms, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. And we know that the mean on that is 9. Alright, so one thing they tell us is that the median is 10. So since the median is 10, that has to be the middle number. So if we start placing these guys in order, that's going to help us give us a little more information. So one thing we know is that because there are 9 terms, there is a true median, a middle term, and it has to be 10. And I don't see 10 on this list, which must mean one of those two numbers has to be that 10. So if I start putting things in order, I had the 0, you got the 4, you got the 6. And so now we're looking at this saying, okay, what does the next term have to be? The next highest term that we have so far is 11, which must mean this is where these guys come in. One of them has to be a 10, and it must be the 5th term in the sequence in order to have a middle term of 10. I need the 5th term to be a 10. Since A is less than B, that means A comes next, which must mean that B is our 10. And now we have the 11, 14, 15, and 18. So we kind of had to use a little logic on that, but this had to be our middle term, had to be a 10. And since they didn't give us a 10, that means either A or B had to be that 10. And because of this statement right here, A had to come first, which made it the 4th term, which made B the 5th term, which is where our 10 would go. So we now know that our 10 can go in right there. So that brings us up to 78 plus A over 9 equals 9. Let me just multiply the 9 over to the right and get 81. So if I subtract my 78, that now tells me my value for A. Alright, going on number 10 here. So population of data, we got 20 terms. It's known that the sum is 560. And then the sum of the data squared is 20,500. So find the mean. So for just finding a mean, remember all that is the sum of your data, which they're telling us is 560. We're also told that there are 20 terms. So that's the number of terms. So real simple right there to get the mean of the data. So 56 divided by 2 gives us the mean. For number 11, this guy's just pure calculator. So just getting the median and the mean, both of those things come right off your calculator when you just put in your list of data into your calculator. So that's something that you should be able to do at this point. So just hit stat, hit edit, put the x's in for list 1, put the the frequencies in for list 2, and then these aren't the right numbers, but I'm just showing you where to go for this. So once you put in the data, you just hit stat, hit stat, go over to calc, one variable stats. You got your x's in list 1, you got your frequencies in list 2. So if you just hit enter all the way down, so if you have the right numbers in there, then you'll get your mean at the very top, which is not this one. I didn't put all these numbers in right now, but you'll find your mean at the top, and if you scroll down, you'll find your median down here towards the bottom. You'll see right there it says median. So that's just going to be pure calculator. Just use the correct list of data and put those in. So for number 12, from November to February, the mean number of accidents was 445. March to October, what was the mean accidents per month for the entire year? So we can kind of just do like a small version of this to figure it out. So we know from March to October, the mean was 340. So that was, or sorry, let me start up with this one. From November to February, so that would account for November, December, January, February. So that accounts for 4 months. Gave us a mean of 445. So remember, this is like the sum of all your terms. So I had 4 of those, plus I had the other 8 months, so 8 of those. And since that was a kind of on average per month, that just means this is what we're using for each month. And so I had 8 of those, and so just for finding the sum, I had 4 of the first one, plus I had 8 of the second one. And dividing by the number of terms, of course, there's 12 months total. So just using that, we can get our mean from that simple setup. Moving on down to 14, just a couple more here. So we got some bivariate data. The correlation coefficient was the negative 0.89. So which one would resemble that? So first of all, it's negative, which means it needs to head in a downward direction. The closer it is to -1, the stronger it is. So that's a pretty strong relationship. So that would be pretty weak. That would maybe be more like a -0.5 or something like that. So that one's pretty strong, definitely stronger than this, and it's in that negative direction. So it's got to be diagram D for this one for number 14. So jumping up to number 15. Get it all on the screen there for you. So, all right. So students marking math determined by 2 components. So you got the IA component, 20%, the external for 80%. The marks for 6 of the students, 2 components are as follows. So they kind of given some table of information right there. So find the regression line. This is just pure calculator stuff. So if we go into our stat edit and put in our list, so clear enter, clear enter. So just put in the data. Let me do that real quick. So that's what it would look like once it's all in. So if you go to stat, go to calc, and go to option 4 for a linear regression line, hit enter on that. We have x's as list 1, the y's as list 2. We do not have a frequency list. So if I just go all the way down, we get all that good stuff right there. So they give you the layout. So I'm going to put the 4.78 in for A, which is like the slope. And then your negative 5.30 go in for B. It's like your y-intercept. You got your correlation coefficient down there if we need that. Remember, if that is not showing up on your calculator for you, you just go under mode, go down to where it says stat diagnostics, and make sure those are turned on. But anyway, so just plug those numbers in for A and B, and you got your regression line. So if this was a student that got 11 out of 20 on the internal assessment part, that was your X's, but was unable to sit for the external. So what mark was she expected on the external exam? So they're giving us an X and they want us to come out with a Y value. So if we take our equation that we just found for part A into that equation right there, and we sub in an 11 for X, that would give us our expected outcome for a Y value. In this one, in spite of what the worked out solution says, it would be accepted because that was interpolation. 11 is somewhere within the range of the data, so that's interpolation, so we do accept it as a likely outcome for her Y value on that one. Correlation coefficient was the R value that I just showed you in the calculator that was on the same screen as that information right there. So moving on down to the very last one, number 17. Again, given a list of X's and Y's represented on a scatter diagram. So when they say use a scale of 1 centimeter to 1 candy bar, in the IB graph paper, 1 centimeter is every 5th line. So let me show you real quick what that looks like. So this is like IB graph paper. I have this on the website. You can download it if you want it. But you see how every 5th line is bold. So that is 1 centimeter. That's 2 centimeters, 3 centimeters, and so on. So same thing on the y-axis, right? Every time you see that 5th line, that's 1 centimeter. That's 1 centimeter. And so that's what they're talking about with that wording on that. So if you're going to graph, that's just how you would want to label your X and Y axes to get those, to set it up the way that they're asking you to. So that's just a basic scatter diagram. You just plot the points like X's and Y's. So the first point you would plot is 240, the next point is 335, so on and so on. So pretty simple, just plot the points, just make sure you use an accurate scale. And on the IB test, you must label your scales. So you have to put numbers in for the X and Y axis in order to get credit for those. Last part on this, so write down the R value and then use part B to interpret the data. So in this case, again, you just put in your list of data into your calculator. I'll do that real quick. So I did those pretty quick. Hopefully I put all the right numbers in there. Always watch out for that on a test because people do put wrong numbers in there. But if I put in all those right, then I'm going to go to Stat Calc, option 4. And again, I got my, under mode, you got your stat diagnostics turned on. So when you go all the way down, you got your correlation coefficient at the bottom. So 0.943 would be the right answer. And then to interpret what that means, there's really two ways to interpret what this means. So first of all, it's positive and strong because it's obviously positive and it's really close to 1, which means it's a really strong relationship. The other way you could kind of throw in some information is to relate it to the actual problem that was tested here. So since it's positive, that means as X increases, Y also increases. So it's like going up to the right, like it's positive. So we could say something like, as the number of candy bars consumed weekly increases, so does the mass for the boys recorded. So number of candy bars increases as mass increases. And so you can relate it specifically to the problem as well.